Math videos. Today's section is 1.6. We're learning about functions. The essential question today is, how do I find the domain and range of a function? Are these words that you remember? We'll find out. First of all, I need to know what is a function. I need to define it for you. A function is a rule that matches each input with one output. And yes, you should put that in your notes, for sure. Here's an analogy that should help you understand functions in a non-math context. I enjoy video games. I grew up playing classic Mario on the NES controller, where you literally just had a little square for your controller, a little control pad, and you had a B button and you had an A button, and that was it. I'm not that old. It was my parents', but I played it. It was fun. Now, each of these buttons in a video game, as you know, does one specific thing. In other words, when you press the button A, that input is going to give you an output of something. So in Mario, let's talk about what the different inputs are, and we'll match them to what the outputs are in the game. Because it's a function, different buttons do different things. So the A button, since we talked about it, is what you had to do to make Mario jump. The B button was what you had to do to make Mario run fast. Obviously, if you hit right, he ran right. If you hit left, he ran left. If you pressed down, he crouched. And up didn't do much most of the time, so let's not talk about that. But do you see how pressing each button did a specific thing? Now, wouldn't it be weird if when I pressed the A button, not only did it jump, but also moved Mario right? Wouldn't that be kind of weird? Like, I don't want to press a button on my video game controller and have Mario do two different things. So this leads us into an important fact about functions, which is that each input should only do one output. And think about video games. You don't want your button to do two things at once. You want it to do just one thing. Each button should do just one thing. So here are some examples of that in a math context. Let's take a look at example number A first. Don't even look at example B. Don't do it. We're just going to look at example A. For example A, we see that we have some numbers that we're inputting, and each input goes to an output. So if you put in 1, if you put 1 into the function, you're going to get out 15. If you put 2 into the function, you're going to get out 10. If you put 3 into the function, you're going to get out 20. And I represented that down here with a table. Usually inputs are the x and outputs are the y. So here's a nice xy table, and we can just see, hey, 1 lines up with 15, 2 lines up with 10, 3 lines up with 20. That's the xy table. Now notice, each input only goes to one output. Just like with Mario, where every button did just one thing, here each input number only goes to one output number. So this is a function because each input only goes to one output. But take a look at example B. Here we have the same numbers. They go to some different places though. In this case, 1 goes to 10 and it goes to 15. 2 just goes to 15, 3 goes to 10, and it goes to 20. And here's the table down here. Now remember, this is a situation where it's like in Mario, if you pressed the A button and it made you jump and run. It made you do two different things. And remember, we said that's bad in video games. You don't want your button that you're pressing to do two different things. So here, the fact that 1 is going to both 10 and 15, see it in the table here, 1 is going to both 10 and 15, that means that this is not a function. It wouldn't work as a video game, and it doesn't work as a function in math. There are some synonyms that you should know in this section, because we're not just going to talk about inputs and outputs, we have other words for that. So definitely get this chart down in your note. We have some inputs and some outputs. Like I said, we already discussed the fact that inputs tend to be x, outputs tend to be y. Another name we have for inputs and outputs is the domain and the range. The domain means everything that's an input, and then the range is everything that's an output. So domain, synonym to input, range, synonym to output. The last synonym that you should know is because we get to choose what we're plugging in, inputs are typically called the independent variable. We are getting to choose what we plug in. We get to choose what button we hit on the controller. This is the independent variable. But the output is the dependent variable. It is dependent on what you input. So for example, I choose to hit A on my controller. That means Mario has to jump. I chose to do this. Mario has to do this. All right, here's some examples from the book. The problems for this chapter aren't too complicated as long as you know your vocabulary. For the following function, they want me to make a table and they want me to identify the range. So here is our function. It's written as a math rule. This is a function. They've given us the domain. Remember, the domain means the inputs, and the inputs are always the x. So let's start constructing our table. We have an xy table, and it tells us that the domain, all the different possible x's that I could plug in are 0, 5, 7, and 10. The way the function works in the math world is we plug those x's literally into the function for x. We're going to see what we get out for y. X is my independent variable because I get to choose to plug it in. Y is my dependent variable because whatever I get out of the function, that's what my y is. So let's start by plugging in 0. Remember, I'm using this function, so I'm going to go 2 times 0 plus 3. Well, 2 times 0 is 0 plus 3 equals 3. So that's my y value when x equals 0. Let's plug in 5. 2 times 5 plus 3, well, that's 10 plus 3, which is 13. If I plug in 7, 2 times 7 is 14, plus 3 equals 17. And finally 10, 2 times 10 is 20, plus 3 is 23. So there's my table. That part is done. It also wants me to identify the range. Now keep in mind, if you remember your synonyms, you know that the range is the outputs, or the y. So everything here is my range. Let's just list it nicely. The range is 3, 13, 17, and 23. Here's our last example for the day. The book might also ask you, hey, here's a table. We've given you the table. I want you to make a rule. And when they say rule, they mean like an equation, something like y equals 2x plus 3. I think that's what we did last time. That's the rule. So what we want to do is we want to look at our table and we want to see what is the pattern here. What's going on? How am I getting from x, my independent variable, to y, my dependent variable? Take a couple seconds and look at that. What do you think? How do I get from 11 to 6? How do I get from 12 to 7? How do I get from 13 to 8? Are you thinking to yourself, you subtract 5? Subtract 5, subtract 5. That looks like a pattern. So if I were to extend this chart to some random x, the way I get from the input to the output is, just like with this one and this one and this one, I need to take that x and subtract 5. That's the rule. So my rule is y equals x minus 5. And here's your summary. First of all, a function is a rule that matches each input with one output. Remember, that's the definition. A domain is a synonym for the inputs, the x's. Range is a synonym for the outputs, the y's. And don't forget that non-functions are those where one input goes to 2 or more outputs. It would be like if we pressed the A button and that told Mario both to run and jump. We don't want one input going to two outputs.